Okay. So I wanted to wish everybody a happy day, no matter what your situation was. So happy Valentine's Day or happy Singles Awareness Day, depending on your situation. So see, everybody's happy today. Uh, All right. So what I want to go ahead and do is we're not necessarily going to go back into the notes that we've been looking at. We will get back to those, but I want to go ahead and just look at some problems to help people feel a little more comfortable with what we're doing, because I'm not quite sure everybody was getting the idea yesterday. A lot of people were doing really well, but I want to make sure everybody's on the same page. So we are talking about the sum and difference identity. So let's start today just as we did yesterday. Let's list those identities. Okay, so let's say I have sine of alpha plus beta. Okay. So what was the pattern here? In the products, do we alternate or do we keep the trig functions the same? We alternate. So with sine we alternate, but we do keep what? The same sign. So this would be sine alpha, sine beta, plus cosine alpha, cosine beta. There we go. Now sine alpha minus beta will look exactly the same, but one detail. Okay, started with a difference, you expand to a difference. So sine of alpha, sine of beta. Oh, I did, didn't I? I said we alternate them, and then I did run it. Yeah. I was just seeing if you were paying attention. There we go. Sine alpha cosine beta plus cosine alpha sine beta. Excuse me, that was my fault. Absolutely my fault. Okay. So now we'll do the same thing here. So sine alpha cosine beta minus cosine alpha sine beta. There we go. Now cosine of alpha plus beta. This is the one where you keep the products the same. Cosine times cosine, sine times sine. Okay. See, that must have been what it was. I was already thinking ahead, 2 steps ahead. Okay. Hello. Hey. Oh, I'm sorry. Right there. Okay, so let's see here. This would be cosine alpha, cosine beta. Now, cosine did do one thing when you expanded it. It switches the sign. Sine keeps the same sign, see plus, minus. But if we start with the sum for cosine, we go to minus. Then it's sine alpha, sine beta. And then if I have cosine of alpha minus beta, cosine alpha, cosine beta, but it's plus. We always change the operation when we expand cosine. Now remember, these rules are reversible, so you can take one that's already expanded and you can condense it back to a single trig function. This one would be sine alpha, sine beta. And the only ones left are the tangents. Okay, so let me write these side by side. So we could have tangent of alpha plus beta is going to equal some fraction. And then we can have tangent of alpha minus beta is going to equal some fraction. It's the only one that goes fractional. We actually haven't seen one of these yet. But the pattern, whether it's a sum or a difference, remains the same. So we have tangent alpha, tangent beta, tangent alpha, tangent beta. And then in each denominator, we have a 1. And then what follows it? What do I do? Oh, we'll talk about the pluses and minuses in just a second, but there you go. We multiply the 2. So this would have tangent alpha times tangent of beta. Then over here, tangent of alpha times tangent of beta. So no matter whether it's a sum or a difference, you have the same form. Now we just need to realize, okay, which one will be the plus and the minus. Like what would go right here? Plus. Whatever operation you have for tangent, keep that operation up top. It's the denominator that switches it. He'll go to the minus. Right, Andrea? Correct. Okay. So if this one is tangent of a difference, we keep the difference, but then go to a plus. Okay. So those are my identities. And Lexi asked the question yesterday, do we have to memorize these? I don't think it's necessary for us. If you want to, is anybody going to do that? Hey, a few people are, okay. But remember, on your quizzes, your tests, you can do what? you can use your notes. Okay, so it really kind of defeats the purpose of memorizing them. I would be familiar with them, definitely know how to use them, which brings me to some of these problems here. Now, I didn't have time to go ahead and copy these. If you want to go ahead and jot these down, or if you just want to follow along, I really just want to go ahead and use some of these and show you how these identities are going to work. Okay? Like, for example, let's say I want to evaluate sine of 165 degrees. You'll notice I started with a unit circle. I want 165 degrees, right? But that's nowhere on my unit circle. Okay, so whether we add two values or we subtract two values, I need two that will give me 165. 120 and 45, that's the first I heard. Okay, 120 and 45, that's perfect. If I add the two, that will give me 165. See, that's what we're doing. We can't evaluate sine of 165, but we can evaluate sine of 45. Oop, parentheses there. Sine of 45 plus sine of 120. And really, only occasionally does the order matter. Here, if I put 120 plus 45, does that change anything? No, changes nothing. So we have the alpha and we have the beta. Okay, so now the formulas that we were just looking at, well, all we want to do is expand them. Okay, remember, does sine alternate or no? Sine does alternate. I'm going to make sure to get it right this time. So I'm going to go ahead and say sine of 45 times what? It would be cosine of 120. Remember, sine, we keep the operation, so now it's a plus. Now what? Cosine of 45, sine of what? Sine of 120. The formula that we just listed, all we do is expand it, and we plug in the values we chose. Are those the only two values that would add or subtract to give me 165? No. And see, it's your choice. Whichever ones, as long as it gives you the angle we're looking for. Okay? So now, here's the thing. We've also been talking about the triangles, but if you're having a little bit of trouble with that, maybe using the unit circle is a better way to go for some people. Because remember, what variable is sine? Is it the x or the y? The y. Okay. Well, what about the cosine? It's the x. Okay. So if I come on over here to the unit circle, I want sine of 45 degrees. Okay. So at 45 degrees, what's the y value? The square root of 2 over 2. Okay, so I'm going to come back over here, so I'm going to replace sine of 45 with that ratio. Okay, and I'm going to do the same thing for the other ones. Now I need cosine of 120. So I go to my unit circle here. Here's 120 degrees. What's the x value? Negative 1/2. Okay. See, it's just like a formula. You're plugging in the ratios now. Plus, now I want cosine of 45. Anybody tell me this one without even looking? What would it be? That's exactly right. Remember, 45 degrees is one of those rare angles where both the x and the y are the same. Now we want cosine, so we want the x. Square root of 2 over 2. Times, and there we go, sine of 120. If I look here, sine is the y value. So square root of 3 over 2. Okay. Now, the way we've also been doing it, I've been showing you from the triangles as well. Okay. So let's take 120 degrees. So 120 degrees is going to put me in the second quadrant. Okay. We're going to create a right triangle. So the reference angle would be 60, right? There's the 30. This is just another way that I was showing you. Well, you remember yesterday, what's always across from 30? Oh, we're so close. 1/2. Across from 60, that's the square root of 3 over 2. And then the hypotenuse is always 1. Now, we're in the second quadrant. So is there anything that I'm missing? What negative? The 1/2, because it's left of the origin, right? Okay. Well, now let's say taking the cosine here of 120 is the same as using this triangle, just using the reference angle. Okay, so the cosine of 120, The cosine is the x value. See, there's the negative 1/2. Okay. Sine of 120, that's the y value. There's the square root of 3 over 2. So if you feel comfortable using the triangles, absolutely go ahead and do that. But if it makes it better, if you feel you can get it done faster using the unit circle, there you go. As long as you're able to do that, I have no problems. Okay. So now what do I do from here? Yeah, there you go. So let's just multiply these together. How do you multiply fractions? Yeah, so what's square root of 2 times negative 1? So negative square root of 2 over 4. Now, if you're adding or subtracting, the denominator stays the same. Okay. Plus, so I know that would be 4 again. But what's square root of 2 times square root of 3? Square root of 6. And again, this problem was nice enough to give me a what? A common denominator. So I can just pull it together over 4. There you go. So you could say the square root of 6 minus the square root of 2, or you could say the negative square root of 2 plus square root of 6. Does not matter. So there you go. Now, would anybody like to see, just like we did yesterday, me plug that in the calculator and see if it gives me the same decimal value as this fraction? You would like to see it? Okay. So let's see here. We have sine of 165. Okay, so sine. Oh, did it again. There we go. Sine. There we go. Let's escape out of that. Of 165. So you see mine's in degrees. Okay. So I got 0.258819. I'm sure it keeps going. So let's plug in control divide the answer we got. So the square root of 6, let's get out of there, minus the square root of 2 over, what was it, 4? Okay. So as soon as I push enter, boom. There you go. Okay. Is everybody kind of starting to get a better idea of what we're doing with these identities? Like how we're actually getting the answer? Okay. All right. Now, you can use the calculator to go ahead and double check your answers, but let's practice putting our answers, let's keep them in the fractions. Okay. So that's why I'm encouraging you to use the unit circle. Let's see, let me go ahead and get out of here. Okay, let's go ahead and choose another one of these. Okay, I'm sorry, what? Okay, now we'll get to a tangent one in just a second. Okay, let's wait on a tangent one. Why don't we do number 4? It says cosine of a negative 105. Okay, so I've got to go ahead and subtract in a certain way so that I get a negative number, but I need a negative 105. So somebody help me out. What 2 measures that I have on this unit circle can I use to get a negative 105? Yeah, but we don't have 15 on here, though. We'd have to evaluate that as well. Okay, so you're saying 30 minus the 135? Would that equal the negative 105? Absolutely. Okay, so we've got my 2 measures. We have everything we need. Now this one, we do have to put it in order. Okay, we're going to want to put 30 minus 135. Okay, so this is cosine of 30 minus 135 degrees. Okay. Is everybody okay with how I chose? And would those be the only ones that work? No. All you need are 2 numbers that will give you what they want. So this one's alpha. This one's beta. Okay. Can someone come on up and show me what the expansion would be? Brandon? Okay. So I keep forgetting. Is this one where the products alternate or no? Okay, so they don't alternate, but there's something that cosine did do. Okay. There you go. Now, he's absolutely correct. We do start out cosine, cosine, and then go sine, sine. But this one's still okay because we're adding, so I can switch those around and it doesn't change anything. That's perfectly fine. Is everybody okay with what he did? Okay. Well, now what? How do I figure out sine of 30 degrees? Yeah, just go to the unit circle. Okay. So here's 30 degrees. Here's the ordered pair. Sine is the what? The y value, so what is that? 1/2. So I'm going to put 1/2 right there, times. Now I want the sine of 135. Okay, so I'm going to come back over here. Well, here's 135. Here's the ordered pair. So is it the negative or the positive? The positive, because we want the y value, right? Square root of 2 over 2. Plus, now let's do the same thing over here. I need cosine of 30. Oh, close. Square root of 3 over 2. There we go. See, that's the x value at that location. Okay. So square root of 3 over 2 times. What's the cosine of 135? Oh, not negative 1/2. Oh. Okay. So here's the 135. Negative square root of 2 over 2. 135 is one of those multiples of 45 where they are going to be the same. Here the sign is just different. So that's a negative square root of 2 over 2. Is there anybody who's not sure how I'm doing this? How we expanded it? How we're getting those ratios? Okay. All right. So let's see here. How about Genevieve? What is 1/2 times the square root of 2 over 2? There you go. She says the square root of 2 over 4. Okay. Plus, now I need square root of 3 over 2 times the negative square root of 2 over 2. Brandon, can you help me out with that one? Oh, yeah, just multiply straight across. I just need the product of those ratios, those fractions. It is, but there's something about it. It's negative because one of them is negative. So what will the denominator be? 4. 2 times 2. There you go. Okay. And now we just pull them together. What is my final answer? Square root of 2. There you go. And actually, how similar is that to the other answer that we got? It's really similar, isn't it? Remember, because we're using the same values to get these new ones, so there's not going to be a whole lot of difference between our final answers. Any questions so far? Okay. All right, now, Brandon was talking about, let's go ahead and do a tangent one. So why don't we go ahead and do tangent of 105? Okay. And I think we had a 105 just a second ago, right? To get this one, we used 30 minus 135. So for this one, why don't we say 105 is 135 minus 30? Okay. Or does anybody want to go ahead and use a different pair of angles? Does it really matter? No? You want to go 360? Okay. Now we're looking for a 105.
Wait, we could go 395.
395?
Yeah, 395 minus
Okay. Point is, I mean, there are different angles that will work. We definitely don't want to make it more difficult than it, needs to be, right? No. Okay, so we're going to stick with 30 degrees and the 135. Okay, so let's go ahead and start here. Now, because we're using the minus, I'm going to go ahead and put the form out, and then let's see if we can get somebody up here to fill in our values. So I know up top, okay, we have tangent of alpha, tangent of beta, then we have 1, and then we always have a product. This is the only one where the formula is a fraction, okay? And that's perfectly fine. So here's the thing, though. Which one of these is alpha? There you go. It always goes in order from left to right. So this one's alpha, this one's beta, okay? Now, should this right here be a plus or a minus? Why? There you go. It's always the same as what we start with. So that's a minus, that's a plus, okay? So can someone come up here using 135 and 30, write out what that formula should be? Well, Brandon, you just came up. I want you to have all the fun. Okay. Who wants to come up? Marcus, were you saying you? What? Okay. All right, so let's do it this way. Let's get a train going. Brandon, since you came up the last time, who would you like to see come up and just set the formula for us? Marcus! That's okay. We're gonna help you. That's okay. There we go. Okay. So I've already got this. What's that? Oh, I thought somebody had a question. I'm sorry. Okay, so I've already got the division symbol for you. So what's alpha?
135.
So what would tangent of alpha be? Tangent of 135. There you go. So all you're doing is just plugging in alpha and beta. So tangent 135. Okay, minus.
And then wouldn't it be like
Tangent what?
30?
Tangent 30. Okay. Over. And see, now we'll fill in the denominator. So see, we have the 1 plus. And then you said tangent of alpha was tangent of 135 times what?
30.
Just 30?
Or 10 of 30.
Tangent of 30. There you go. Perfect. Okay. See, there you go. Nice. That's it. See, it's just a formula. All you're doing is plugging in the values that you have. Is this starting to help people see it a little better? Is anybody confused? Okay. Now, this one won't be, unfortunately, just as straightforward as the cosine and sine, because what is tangent's ratio? Remember, cosine was x, sine was y. So, Brandon, what is it? Oh, I thought you were raising your hand for that.
If you're going to ask me, it's the ratio.
I'll tell you what, if you come up and give me the ratios, I'll let you go.
The ratio for what again?
If you give me the ratio for tangent 135. Because what is tangent's ratio? It's what over what? It's always y over x. So if I want tangent of 135, at 135, I want to take the y value, okay, and I want to divide it by that x value.
So the square root 2 over 2 over negative square root 2.
Okay, so he says the square root of 2 over 2 over the negative square root of 2 over 2. Well, what's that?
Y over x.
Oh, it is y over x. Okay, now let's take a step back. What if I divide some value by itself?
It'll be 1.
But one of them's negative.
Yeah, so it'll be negative.
Yes. So that's negative 1. Okay. So tangent 135, I'm just going to put negative 1 minus. Okay. Now I need tangent of 30. Okay, you answered it. So there you go. Now I need somebody to help me with tangent of 30. Okay. And Brandon, since you answered that question, who would you like to have been told later after you come back answered this question? Nathan. All right. So Nathan, I need tangent of 30. So at 30 degrees, here's my ordered pair. So I need to take this y value, and I need to divide it by this x value. Okay. So Nathan, can you come up and help me? All right. Thank you, sir. Okay, so tangent is y over x. So I want to take the y value from that ordered pair and divide it by the x. So what's the y value? 1/2. What am I going to divide that by? Okay, so I'm going to take 1/2 times what? 2 over... There you go. He's absolutely right. Remember, when you divide by a fraction, we multiply by the reciprocal. So that's why he flipped it. Well, what are those 2's going to do? They're going to cancel. Now I've got 1 over the square root of 3, but what does that mean, rationalize? Okay, multiply by the denominator. So that would be square root of 3 over 3. Perfect. Thank you. Thank you. All right. So this right here, tangent of 30, ended up being the square root of 3 over 3. Okay. Now the rest of them, see, we already know. We have this 1 right here, so 1 plus. What was tangent of 135? That was negative 1 times what was tangent of 30? Was it negative? That one was positive. The only reason this one is negative is because, remember, in the formula, we were subtracting it. So square root of 3 over 3. And there we go. Now, this one's going to take just a little more algebra to finish up. Okay? Let's take a look at what we got. I have negative 1 minus the square root of 3 over 3 over, well, you're multiplying that by a negative, so that's going to be 1 minus the square root of 3 over 3. Okay. Can they cancel? Yeah, because see, they're both negative, but these are both opposites. So even if I were to pull the negative out of this one, it would change that sign. So unfortunately, we still can't do that. All right. So what I would do first, what's one thing that in math people don't really like to work with? The fractions, right? So I would go ahead and multiply through by some number that's just going to get rid of that 3. What do you think is going to do that? Yeah, just multiply through by the denominator. Okay, so let's see here. Now we do have to distribute. So what's 3 times negative 1? Negative 3 minus. Now when I multiply these, those are going to cancel. So I've got the square root of 3. Okay. There you go. So it would be positive 3 minus the square root of 3. So that looks a lot better than what we've had, right? Now, here's what we want to do. We still want to rationalize this. What am I talking about? What does that mean? There you go. But if it's a binomial, I can't just multiply by the square root of 3 because that's not going to get rid of the radical. There you go. What's the word I'm looking for when you factor a difference of squares? You got to multiply by its conjugate. In fact, what's the conjugate of 3 minus the square root of 3? There you go. 3 plus the square root of 3. Does that make sense? Okay. Now, how do I multiply binomials? What's that acronym we use? FOIL. Okay. So I'm going to go ahead and just multiply these together. So somebody help me out. Here's the first. What's negative 3 times 3? Negative 9. Now I want negative 3 times square root of 3. There you go. Now, why can't I multiply the 3 and the 3 together? What's protecting this one? The square root. So this one's outside, that one's inside. I can't multiply those together. It's got to be minus 3 square root of 3. But now, what happens when I multiply the inside? Oh. Again, it's the same thing. It's just that this one's negative, that one's positive. Okay. So minus 3 square root of 3. And then now we're going to multiply the last. So negative square root of 3 times square root of 3. Negative 3. What happens when you multiply a radical by itself? Those radicals do what? They cancel. They're gone. Okay. Now, below, we do recognize these as what? We actually made them conjugates, right? Well, if we know they're conjugates, we only have to multiply what 2 products? First and last. Would anybody like me to just go ahead and multiply the whole thing to show you that the outside and inside will cancel? No? Foiled again. Okay. So let's see here. What is 3 times 3? 9. That's the first. Now let's multiply the last of each group. So negative square root of 3 times square root of 3. Minus 3. See, now we don't have a denominator that's a radical. We rationalized it. Let's just simplify. So up here, what's a negative 9 minus 12? Did I say it? What's a negative 9 minus 3? Negative 12. Yeah, I'm getting ahead of myself. There you go. Negative 6 square root of 3. Think of the radical as a variable. Okay? All over 6. Okay. Is there anything else that can be done? Yeah, you'll notice if you end up in a situation where both of your numerators can simplify with your denominator, I think it's always a good idea to do it. If only one of them would simplify, I probably wouldn't worry about it. So I'm going to go ahead and say negative 12 over 6 minus, because we have this minus right here, 6 square root of 3 over 6. So what's negative 12 over 6? Cool. Negative 2 minus what? Square root of 3. There we go. Now see, that one took a little bit more algebra simply because we started with a fraction. They won't always do that, but if one of them's going to, it's probably going to be tangent. Okay. Now let me actually show you this. What was the original problem we were solving? Tangent of 105? Okay. So let me come on over here. Tangent. No, I did it again. Tangent of 105. Okay. So I'm getting a negative 3.73 and then a bunch more numbers. Okay. So let's see here. Our answer, we got negative 2 minus the square root of 3. So negative 2 minus the square root of 3. Okay. Gives me the exact same response. Okay. So these new identities, they are just formulas. You're just plugging in. From there, it's really the algebra that takes over. Okay. Do you guys think it's easier that we're looking at it now using the unit circle? Does that make it easier for some folks? Okay. If that helps you, please, by all means, go ahead and do that. Okay. So last thing I want to show you, and then we'll go ahead and stop for today because you guys have done a great job, like always. Okay. Let's say you come across one like this. Okay. So it's tangent of 5 pi over 12, but it's in radians. That is exactly what I would do. You still need to go ahead and find two values that'll add or subtract, but a lot of people find it difficult to do that with radians. Degrees are a lot easier to work with. How do I change 5 pi over 12? There you go. Brandon says multiply by 180 over pi. So the pi's cancel. How many times will 12 go into 180? A little higher. A little higher. A little lower. How many times will 12 divide into 180? 15. There we go. So 12 goes into itself once, and 180, 15. And what's 5 times 15? 75. So this is really tangent of 75 degrees. So see, even if you're given a radian measure, just go ahead and use the degrees if you want to. If you feel confident enough to use the radian measure, that is fantastic. Okay. So now, Rozzy, I need two values that will add or subtract to give me 75. $45 and $30. That's exactly right. So in order to simplify this, just like we've been doing all day, I'd go ahead and say tangent of 45 plus 30. And see, here's your alpha, here's your beta. Okay. And then what would we do from here? Yeah. Mm-hmm. Okay, so tangent 45. Would that be a plus or minus? Plus tangent what? Beta, which is 30, over 1 minus, because it always changes the sign below, tangent 45, tangent 30. And then you would just simplify. Using the unit circle, get your fractions, those ratios, and then just get your final answer. Okay, is there anybody confused by what we were doing today? Anybody having a hard time? Okay, good. Well, I'll go ahead and stop there. if you want to, where did I put it? Thought I had this. Here we go, right here. This one, if you wanted to go ahead and continue, get a little bit of practice, I'll go ahead and tell you this one right here should come out to 2 plus the square root of 3 as your final answer. Okay. Now, also, one thing I want you to see, what was the answer for this one here, the tangent 105? It was -2 minus the square root of 3, right? Again, how similar are these answers? Really similar, okay? Because we're using just a certain set of values to get others when you add or subtract them. Okay, well, there you go.